Shiba Vasudevan, President of ITE Hamilton Session. Thank you for being with us today and welcome to our second virtual speaker event of this year. Before we begin, may I request everyone to please mute your microphones? Thank you. Today's speaker event will be divided into two parts. The first part will include two student presentations made by the students from the McMaster University. The first student presentation will be on evaluation of Ontario transportation electrification policies using interpretable optimization approaches. And this presentation will be made by Anastasia Surkov. The second presentation will be on security and data privacy issues of integrating vehicles into the network systems. And this will be presented by Mo Mirza. After both these student presentations are over, we will open the floor to questions on these presentations. And in the second part of the event, there will be a presentation by Phil Weber of CIMA on accommodating pedestrians and cyclists at roundabouts. So with that, let's move on to the first student presentation by Anastasia. Anastasia, please go ahead and start your presentation and start sharing the screen.
All right, give me a second. You didn't get. Oh. Let's go here. Sorry, give me a second. All right, so you should see the presentation mode, I believe. Okay, so I will, thank you so much for the introduction. I am Anastasia, as Shiba mentioned. I'm doing my Master's of Applied Science, the Civil Engineering Department with Dr. Motaz Mohammed, and today I will just be showing briefly, trying to summarize one of the projects I did, and Dr. Motaz provided feedback, as well as Dr. Zoe Lee, and it was through the application of optimization approaches to provincial greenhouse gas emission reduction policies. Okay, good. So for some background, Canada, as you all may be familiar, Canada, as well as over 150 other nations, have pledged to reduce greenhouse gas emissions. Our federal target is a reduction of 30% of greenhouse gas emissions by 2030. As of recently, you may have also seen in the news, Canada has pledged to, along with other nations, have pledged to meet a net zero emissions by 2050. Concrete plans on how that will be achieved have yet to be formally announced. And as this is a transportation-related presentation, I took a look at the transportation greenhouse gas emission sector. So by economic sector, transportation makes up a quarter of emissions. This is from 2017, but the proportion has stayed relatively constant. I'm not sure, actually, now thinking back to how COVID may have impacted it, but I am sure that the proportion is still somewhat similar post in the following years. It will be somewhat similar. So in terms of federal, my scope was looking at the provincial and federal policies, but looking at the provincial cost, specifically Ontario's. So I should start by first briefly outlining what federal policies exist that tackle greenhouse gas emissions in the transportation sector. So if you take a look at the Pan-Canadian Framework on Clean Growth and Climate Change, the main policy, and this is carbon pricing, and this reaches past transportation to all different sectors which that produce carbon emissions and are more carbon intense. So transportation is impacted in that, and this is just the schedule for the carbon price per ton of CO2 throughout the years to year 2030. And again, that is the scope that I'm looking at. It was just a short term from 2020 to 2030 greenhouse gas emission reduction. At the federal level, there's also vehicle electrification. So there's EV incentives for passenger vehicles, and there are electric buses that the federal government is helping to subsidize. There's also passenger car emission regulations. So each new model year vehicle needs to be reach certain CO2 emission operational improvements. And there will be the clean fuel standard, which will reduce the carbon intensity of fuel over its life cycle through the blending of using renewable fuels and alternative fuels in gasoline. In terms of Ontario, things that also tackle passenger transportation are we're investing a lot of money into transit. So mostly into subways, also light rail expansion, just improving the transit network, which in the short term may not see a lot of greenhouse gas reductions. It's more of a long-term investment, and the short-term investment has been was recently announced last year, where we are now blending fuel with renewable fuel to decrease the CO2 emissions over its life cycle. So that's under the Cleaner Transportation Fuels Regulation. So I was thinking, well, what if we also looked at vehicle electrification in a similar way that the federal government looked at? So as you may know, and a few of you may have seen from a presentation I made 2 years ago, maybe at the CITE, at one of the CITE events, Ontario used to have electric vehicle incentives. So I was thinking, what if we brought them back in addition to electric buses, in terms of that, and what will be the costs and what will be the greenhouse gas savings to that 2030 year time period. So that was exactly the aim, and I had that question in my mind. I took a course last fall, and that's where this presentation kind of and report came from, on an optimization course. And I was like, well, let's use these optimization methods to evaluate the optimal allocation of policy and costs to reduce greenhouse gas emissions within the sector. And I found that it may make a more easy and more interpretable way of seeing how this greenhouse gas emission reduction policies can be made and chose in the future. So this is the quick, I know this is lunchtime, so it's not supposed to be math heavy. I'm supposed to be giving you guys a break. So just to be brief, these are the 4 policies I considered. So BEV incentives and PHEV incentives refer to battery electric and plug-in hybrid electric incentives. So this 3,000, so this is from the perspective of Ontario. And so this is assuming that we will reintroduce these policies, and support these policies and pay for these policies. So what will be the 10-year cost of all of these policies to get to a greenhouse gas emission goal? So BEV incentives, I just assumed was $3,000 per incentive. This is what British Columbia is charging or is giving out to people who purchase a new battery electric vehicle, and $1,500 for a plug-in hybrid electric vehicle. So those are the first 2 policies, X1 and X2. And then the other 2 policies I considered was from the provincial fleet perspective. So what is the relative total cost of ownership? That's what TOC is, for a government battery electric vehicle and for a battery electric bus replacement. So these are relative to the conventional option. So in the case of government battery electric vehicle, it's just a conventional car. And in the case of a battery electric bus, it's just a conventional diesel bus. And you can see that there's a range of total cost of ownerships that I just included. So it could be for a battery electric car, it will always be an increase. The total operational cost of a battery electric bus or car is cheaper than a conventional gasoline car. So that's why it's positive. So it's up to $9,000 in savings or $3,000 in savings. And then the total cost of a battery electric bus is estimated now to either be break even when you include all of the maintenance that now it will need less maintenance and those maintenance costs, or it will up to the negative, which is $75,000 more expensive than the diesel bus. So I considered this range of total cost of ownership, and I considered a range of EV sales. So the EV sales is important because it will determine how many incentives, assuming we keep this $3,000 and $1,500 price fixed, this will assume how much money the province will spend funding this incentive program. So you can imagine different combinations of all of this, and it was just an optimization equation. So it found just the optimal allocation of policies, so X1, X2, X3, and X4, to get a greenhouse gas reduction. I will show in the next slides, the greenhouse gas reduction. I wasn't able to get to that 30% greenhouse gas target, but that target honestly is a bit arbitrary. That target comes from all sectors reducing greenhouse gas emissions as a whole. And I was just trying to get passenger transportation to 30%, but I was not able to get that with these combination of policies. And again, I just want to emphasize the idea of this comes from switching one car, a conventional car, over to a clean car and an electric car. And it's clean in the province of Ontario because we have the clean electric grid. And we also have a surplus of electricity, so we can support the vehicles that I've modeled within this time frame. So that's where the savings come from. And again, the costs come from either incentives and the relative total cost of ownership. And also in the background, I just considered if the province did nothing, there are still federal initiatives going on that will reduce the greenhouse gas emissions. So again, as I kind of alluded to, there are model constraints, and I mentioned EV sales, you can only reach so many sales in year 2030 for it to be realistic. So that was really a constraining thing to the model, because if we were able to sell, 100% of all the vehicles sold in year 2020 were electric, that would be great, and we would be able to reach that 30% greenhouse gas emission target, but that's not a really realistic goal. For government vehicle replacements, there's just a fixed number of government vehicles are on the road. You will see it's not that many relative to the personal cars on the road. And then the targets, again, this was like the greenhouse gas emission target. And the model is not able to meet that 70% of 2005 CO2 equivalent levels. That's that 30% target. It was not able to meet it because of the EV sales constraint and the government vehicle replacement constraint. So this is just an overview of the results. You can see if we start off in year 2020, we are now 8% of 2005 levels. That's our starting point. And if the province does nothing, we would see a reduction in 2030 of 17%. In this in the passenger transportation subsector. But if the province acted with our policies, we would see up to 26% reduction in emissions relative to below the 2005 levels. So that again assumes for that upper bound of EV sales. To also overview the amount. So this is a graph of the costs, savings, and allocation of greenhouse gas policies. So the bars are representing billions of Canadian dollars over a 10-year period. And the magnitude obviously corresponds with the amount of money that would be spent for that policy. And in brackets, you can see the units of policy. So the BEV, the X1 and X2, the BEV and PHEV policies, they're much more numerous, and the incentives are doled out for the 10-year period are much larger than obviously the X3 and X4. And again, those policies correspond to how many government vehicles are on the road that can even be replaced. So you can see a lot of the savings because of the on-road emissions come from private vehicles, and that is kind of what we have to target. And just because of the 4 policies I considered in this model, a lot of the cost also comes from flipping over those personal vehicles in comparison to flipping over the provincial vehicles, which could be said is much easier to flip over. But again, the impact will be it's much harder to get that impact of greenhouse gas emission savings from the passenger transportation sector. So, and this is also my final finding I wanted to really emphasize. It's this greenhouse gas abatement. Just pay attention to the column that I have circled here. So X1 and X2, those first two chunks, this is greenhouse gas abatement is like in economic policy terms is the amount of money it takes to reduce a ton of CO2 emissions, and it's associated with policies. So in Ontario's case, from the model I estimated, it would cost between, if you average both incentives, the incentives have a greenhouse gas abatement cost of around $1,200 per ton of CO2. So that means if the province spends $1,200, it will reduce only 1 ton of CO2. So just for a comparison, it's a quick comparison, the carbon price we saw is much lower than $1,000. But obviously these two policies have different mechanisms at hand, but you can see the cost of reducing emissions in the sector is very expensive as is. The negative prices for the third policies, government BEV replacement, is negative because, again, it's cost savings. Because it is cheaper to own and operate a battery electric vehicle than a conventional vehicle over its lifetime, assuming it's, again, the infrastructure. This also accounts for charging infrastructure and the cost savings because of operational maintenance. Yes. So all in all, over the 10-year period, these policies would cost $3.8 to $3.1 billion over 10 years. But for reference, that is only 0.1 to 0.2% of annual programs budget for the province. So while it's a huge number, if you break it down per year and then make it relative to the provincial budget, it's not that much. However, it is extremely expensive in terms of greenhouse gas emission reduction policies. And in terms of the most cost effectiveness, the EV replacement is the most cost effective for the provincial EV replacement because it's cost saving, then the battery electric buses, and then the personal EV incentives. But as I mentioned, there's also a range of greenhouse gas emission reduction costs. I only looked at a fixed greenhouse gas emission reduction, but in reality, there's such a large range depending on who chooses, what someone's vehicle is before they purchase an electric vehicle, and that will influence the range of greenhouse gas emissions saved, you can imagine. And to conclude, there are this comparison that I made, just it makes it easier to visualize the decision making involved in choosing a greenhouse gas emission reduction policy. It's also based off of a ton of assumptions, but if you're making these assumptions in the background, presenting it and using the optimization model makes it kind of more transparent that way. EV incentives are also very expensive, but they are needed to realize the large greenhouse gas emission reduction in my policies or in my analysis. However, there are revenue neutral and revenue generating policies which can be considered in the short term, and other provinces are considering them, like the EV sales mandate, for instance. Quebec is now encouraging or requiring certain manufacturers to sell a certain percentage of electric vehicles, and also congestion pricing. While modeling it may be tricky, it will be in the short term revenue generating and will induce a reduction in greenhouse emissions, which may also be able to feed further greenhouse gas emission reduction policies, which are more expensive. So just to acknowledge my research grants that I received. And yeah, this is my email. And as I said, Dr. Motaz Mohammed and Dr. Zoe Lee provided great feedback and also encouraged me to develop this more into a presentation and a more fulfilled, legitimate, I guess, paper. All right, thank you so much. Just the references.
Thank you, Anastasia. That was a wonderful presentation.
Thank you so much. I'll stop.
Now we will move on to our second student presentation on security and data privacy issues of integrating vehicles into the network systems. And this presentation will be made by Mo. Please go ahead, Mo, and start sharing your screen and make the presentation.
All right, hey everyone. Let me just get the screen started. So first off, right off the bat, I want to thank Anastasia for her presentation. Learned a lot about EVs and GHG emissions, and I'm looking forward to Phil's presentation later on today. And I'd like to thank Omar, Adam, and Sheba, and everyone from the Hamilton section for organizing this event. Hamilton means a lot to Anna and I, and pretty much everyone at Mac and Mohawk. So it's always nice to have these events, even though they're virtual, and it is convenient because like my bedroom's right behind me, so no commute. But it is nice seeing people in person, so hopefully that could happen next year. And today I'm going to be talking about security and data privacy issues of integrating vehicles into network systems. Now, first off, ignore the Starbucks, but one theme I want to drill down in today's presentation is how modern automobiles are pretty much large-scale computers. They're being heavily integrated into network systems. And an example of that is with the new Teslas, when you want to upgrade your Tesla, you purchase the upgrade online via their website. And just like a software upgrade on your phone, you go in on the dashboard and upgrade it. Now, the ability for these vehicles to have embedded computer systems is obviously an amazing technological advancement. For some reason, this thing keeps moving. And however, there comes a cost. These vehicles are left unattended in public places, and with expanding network infrastructure, this leaves our vehicles vulnerable to an attack without us even knowing. So next off, a quick overview of what this presentation entails is we're going to be touching on and understanding security and data privacy issues in modern vehicles, as well as touch on practical applications and potential solutions. So no pun intended, this is about breaking into your car. So we've broken down security and privacy issues into physical security and applications and communication security. As mentioned previously, and with the theme about how massive vehicles represent pretty much massive computers, one object that aims to take advantage of that is this 30 USD dollar device, which is called a roll jam. And how it works is it pretty much attacks keyless remote entries to allow an attacker to unlock your car. And how it works is it records and blocks the radio signal to the key fob and replays the action. We'll be watching a video by CBC Marketplace, a really short one right after this. And how it pretty much works is an attacker just needs to put it near a target vehicle and wait for the victim to use the key fob within the radio range. And several other attacks include the relay attack and bypass kit, which are similar, however, they're slightly different. Now, modern day vehicles obviously are aware of that. And for example, the Tesla has new technology where it has sensors all around the car, so it records if anyone's near your vehicle while it's left unattended. And however, it is only a matter of time before they're exploited. So let's watch a video by CBC Marketplace.
Cars are now pretty much just computers on wheels. So like a computer, they're vulnerable to various types of attacks. Currently, we see it's locked.
Yep. Can't get in.
And then, just using this. Pretty much all vehicles have this same defect.
Now, there have been a couple cases in Quebec where it's been reported that someone got into a car using the roll jam. However, hopefully in the future it doesn't happen to anyone. And next up, we're going to be touching on applications. So applications for automobiles are designed to be more accessible for multiple vendors, considering they're not usually made by the same original equipment manufacturer. That they have like third-party people doing them, third-party companies doing them for them. So although this allows them to maintain a low cost, it limits the control and reliability of the application, which can lead to a data breach or an error, which can give an attacker full control of the vehicle. Now, multiple embedded computer systems from different vendors are typically integrated into a single platform, and this hinders the reliability of the application because every company has different assumptions while setting up their software, and they'd have to test every single exploitable combination of issues, which may not always be apparent and also will be very costly and time consuming. And next up, when looking into practical applications, we want to look beyond the car we have lying in our parking lot and look into the entire road network, and in particular, look at buses. Now, one thing we have to take into account is many vehicular applications and services are not designed with security in mind. For example, when it comes to car ads, you don't really hear about security. And this could lead to several issues with vulnerability. Now, the first thing we've noted here is gaining access to ECUs. Now, mind the jargon, ECUs represent electronic control units, which pretty much mean an attacker has control of the entire bus, including the steering and brakes. Therefore, you could picture how much of a negative scenario that could be. Secondly, when accessing communications, we pretty much are talking about the message board that displays the route right in the front of the bus. For example, it could have the bus route, it could have a special message like "Go Leafs Go," which didn't work out last night, or therefore if an attacker has access to it, they can change it. And there are potential solutions, however. So we've talked about two issues where attackers leverage vulnerabilities to gain access to the electronic control units. And when it comes to the message board, it's all broadcast without any authentication. And a security technique which helps protect these internal bus networks includes cryptography. Now, the word cryptography, you might have come across it because of cryptocurrencies and Bitcoin on the news lately. And how it pretty much works is it's a mathematical computational practice of encoding and decoding data. So this table pretty much shows like the whole process that of authentication that would take place just to protect the internal bus network. And in summary, the Cliffs notes are: we need to think holistically beyond the vehicle we have parked in our parking lot and into the entire road network and all of society. And with that, I'd like to thank you for your time.
Thank you, Mo. That was an interesting presentation.
Thank
Now
you.
let's open the floor to questions to both of these student presentations. To ask your questions, either please raise your hand using the hand icon, or please enter your questions in the chat box and we will take it in sequence.
Shiva, can I ask a question to Anastasia?
Please go ahead.
So Anastasia, if you look at, like, for example, the short term up to 5 years, what is your recommendation on a federal level? Is it to reintroduce the incentives for purchasing an EV, or should they try to maybe integrate it more into their the public transit systems?
Yeah, that's a great question. I would, if I were to make a recommendation, reducing greenhouse gas emissions is urgent, and even with the high price point of incentives, it is still it's still cheaper in the long run to spend all the money we can to address climate change. So that should be the first and foremost idea. But if you're looking to spend money more efficiently, incentives obviously there's some provinces that are facing some that are doing the electric vehicle incentives, and it's an excellent way of instigating and increasing the sales of electric vehicles. However, they should be consistent. They shouldn't be canceled and then not canceled and then cancel again. So there should be leadership in terms of really fostering that industry, and then it should be clear that ultimately they will be waned down and an EV sales mandate may be introduced. And also topics, if you were talking about electric vehicle incentives, there are issues concerning equity and who the incentives are going to, and people who purchase electric vehicles, as they have a higher price point, are usually more well-off people. So there are also equity concerns from that perspective. So I mean, as policies go, it's expensive, but there's a role and a place for EV incentives. So that's my answer in short.
Thank you.
Thanks, Anastasia. We have another question from Omar. Omar, please go ahead.
Thank you, Sheba, and I want to take the opportunity to thank both presenters, Mo and Anastasia, for the wonderful presentations. Quick question for Mo. Given that there's a lot of research going on for connected and autonomous vehicles, do you think from a literature review and from a policy perspective, does the existing rules and regulation for cybersecurity is by the province of Ontario and the federal government, is it sufficient to protect the future road users of fully automated vehicles or even connected vehicles, which we're trying to connect infrastructure with vehicle, and what kind of implications would that increased connectivity have, and whether are we protected from a legal and regulatory perspective as of now or not? It could be just yes or no.
Oh, that's a great question, and it's pretty interesting that you mentioned that. So my presentation revolved around ITS, and there happens to be a whole subsection of the whole ethics and how ethics plays a role with autonomous and connected vehicles, which is, I don't think anything is finalized until I think we're on level 3 connectivity right now. So maybe when we reach like level 4 or 5, more of those rules will surface, and hopefully there's no vulnerability of someone like a malicious user attacking the road network. However, I don't think the infrastructure is there yet. It's an ongoing process, and it's only until we reach level 5 that we might be able to see it.
Perfect. Thank you.
Thanks, Mo, for answering that question. I'll give it a minute for anybody to ask additional questions. I don't see any more questions, so let's move on to the second part of the presentation. In this section, Phil Weber of CIMA Plus will be presenting on accommodating pedestrians and cyclists at roundabouts, and his presentation will also cover topics on design treatments, safety and security issues, accessibility, and some experience from Netherlands. Phil has more than 20 years of experience in the transportation field, and he is considered a national authority on roundabout planning and design. And with that, I will welcome Phil to share some insight on the most requested topic by the Hamilton section members, and that is the roundabouts. Phil, the floor is yours. Please start your presentation and share your screen.
Okay, thank you very much, Sheba. Hopefully everybody can see my screen about now.
Yes, we can.
Excellent. Thank you, and thank you, Anastasia and Mo. Those are two interesting presentations, interesting subject matter for sure. Okay, thank you everybody and thank you, Adam, for inviting me to speak today. So my presentation is Pedestrians and Cyclists at Roundabouts, and Adam, I think I have about 45 minutes. If that's correct, I'll try to stick to my timeline. I think we're wrapping up at 1:30, right? So I'll hopefully keep things on track.
Yeah, that works, Phil.
All right, thanks. I always try to stick to my schedule. First of all, some advantages of roundabouts and some disadvantages, just to give a very quick high level, and I'll keep this to just 2 slides. One of the big advantages of roundabouts and reasons that road agencies are putting them in is that they're safer for motorists. And one of the reasons they're safer is that we avoid these types of crashes, the T-bones and right angle crashes that injure people. So that's a big reason that roundabouts are going in. They're also good at managing access, things like, we can put them in, and instead of making a left turn, you can make a right turn and a U-turn, or a U-turn and a right turn. So that's another advantage of roundabouts. Also, no signal maintenance. They work during power outages, which can be pretty handy. Lower delays, fuel consumption, and emissions. That's a nice reason to put in roundabouts as well. Also, streetscaping opportunities. So all these are good reasons to put in roundabouts. But roundabouts come with disadvantages as well. Nothing's all pros and no cons. One of the big ones is higher construction costs. Not always, but most times. So that's a big disadvantage. Another one is they require more space at an intersection. So those are two big disadvantages right off the bat, and that's why we're not putting them in everywhere. Something maybe not quite so obvious. With roundabouts, they're harder to prohibit certain movements or provide transit priority. So that's another reason that we may not want a roundabout everywhere. Also, roundabouts require public outreach and education. So maybe not on the part of a consultant like myself, but if you're a member of the road agency, that's perhaps a disadvantage. They require more work. You got to give the public, education on how you use them, how you drive them, all that sort of thing. And a final disadvantage, roundabouts don't have pedestrian signals, and sometimes that's a pretty big disadvantage. And we're going to talk a little bit more about that. Just some terminology, just to bring everyone up to speed and put everyone on the same page. Roundabouts have a central island, they have splitter islands, they have a yield line. And now at the bottom, hopefully everyone can see that, roundabouts have crosswalks. A few more terms. There's a crosswalk setback, and that's usually 6 to 12 meters typically. And the idea there is that as a driver, when you're approaching the roundabout, you want the crosswalk set back from the yield line so that you're separating the driver tasks of looking for pedestrians in the crosswalk and then looking for circulating traffic. If the crosswalk were right at the yield line, of course, most drivers will end up just rolling right through it as they're looking to the left for oncoming traffic. So we set the crosswalk back to separate those driver tasks. Then there's a refuge width in the splitter island so that we have a two-stage crossing. And we typically want that to be a minimum 2 meters. More is, of course, better. This particular roundabout is on a road with bike lanes. So here the bike lane terminates before the roundabout, and we'll talk about that, why that is. There's a ramp to the sidewalk. Usually the sidewalk is wider. And then on the exit side, the bike lane re-enters the road. So just some terms that we'll talk a bit more about some of these terms a little bit later on. As for an agenda, conditions for pedestrians at roundabouts, conditions for cyclists at roundabouts, radial versus offset left design. What the heck is that, you might ask? Roundabout design in the Netherlands. Of course, for those of you that are not familiar, Netherlands is where everybody bikes all the time. So we'll talk about what they do for cyclists at roundabouts in the Netherlands, and they do a lot. Some really cool stuff, and then some concluding thoughts. So conditions for pedestrians at roundabouts. So there are 4 components of the pedestrian experience at intersections, of which, of course, roundabouts are an intersection. There's statistical level of safety. There's the feeling of safety, which is security, level of accessibility, and convenience. Whoop, what have I done? All right. First, some quotes. These are mostly US sources here. In fact, I think they all are. Current international research shows that modern roundabouts improve vehicular and pedestrian safety compared to conventional intersections. However, their effects on pedestrian safety in the US remain unsubstantiated. Complicating this problem is the scarcity of pedestrian accident data at roundabouts, especially at intersection locations that were reconstructed as roundabouts and potentially provide critical before and after accident statistics. So, this is a quote that's saying, well, current international research shows that roundabouts are good, but what about in the US? Here's another quote, again, the US. Literature shows that properly designed single-lane roundabout motorist and pedestrian safety is almost always improved. So, single-lane roundabouts are good. In general, multi-lane roundabouts are not recommended in areas with high levels of pedestrian and bicycle activity because of safety concerns of multiple threat crashes for pedestrians, especially those with visual impairments and bicyclists. So single-lane roundabouts are good, multi-lane roundabouts not so much. And then this is just kind of a general quote. The real advantages of roundabouts is that they keep traffic movement. And that's kind of a real general consensus, is that roundabouts are good for motorists, but not so good for pedestrians and cyclists. Well, here are some of the safety numbers anyway, and this is the US source here, the Federal Highway Administration and Insurance Institute for Highway Safety. So overall, in terms of crashes, 37% reduction. This is motorists. 75% reduction in injury crashes, 90% reduction in fatal crashes, and in terms of pedestrian crashes, about 40% reduction. So that's pretty good, right? Now, mind you, some of these, the last two columns are dealing with some pretty small sample sizes, but even so, a 40% reduction in pedestrian crashes is pretty good. Here in Ontario, there's a study of 30 roundabouts. This is on the Region Waterloo website. This found that pedestrian collision rates are approximately 40 to 60% less than pedestrian collision rates at comparable traffic signals with similar traffic and pedestrian volumes. So the safety science at roundabouts is pretty favorable in terms of pedestrian collision rates. Why are roundabouts safer for pedestrians, you ask? Well, traffic speeds are lower, so this gives pedestrians and drivers more time to judge gaps and react to each other. Crossing distance is less. You're only traveling across 1 or 2 lanes at a time as a pedestrian. You're also watching for traffic in only one direction at a time. And as a driver, you're more likely to be looking to where the pedestrians are instead of up at the signals or left while turning right. Here's your typical signalized intersection, right? And I'm, you know, the terminology is, you know, you push the button, you get the pedestrian signal. And I hear people say this all the time. I push the signal and it's safe to cross. Well, actually, you know, the proper term should be it's your turn to cross, right? Because often drivers turn across the pedestrian crosswalk, and this is where pedestrians get hit, right? It's when they have their walk signal and it's their turn to cross. So pedestrians get hit when they have the right of way most of the time. So it's very rare the pedestrian gets hit when the driver violates the red, right? Most of the time, pedestrians get hit when drivers are turning left or right across the crosswalk. But pedestrians feel quite safe when they have the walk indication, even if they're not necessarily safe. So it's a safety versus security thing. So security is, of course, the feeling of safety. Pedestrians feel very secure at signalized intersections, even if they're not necessarily that safe. But back to the roundabout, there is a perception that roundabouts are not as safe for pedestrians as a signalized intersection because they don't have that positive exchange of right-of-way priority. And that's not entirely unfounded. Not everybody is comfortable finding or creating a gap in traffic in order to cross at a roundabout. And it depends on the roundabout, right? Seniors can find this task difficult. Children may not have the experience or confidence, especially at busier roundabouts. And of course, persons with vision loss may have problems finding the crosswalk and determining where to cross or when to cross. There was a report done in the US, it's a number of years ago now, it's called NCHRP Report 674. And it's a study that looked at 3 single-lane roundabouts and 2 two-lane roundabouts. Not a big sample, some of these reports are like that. And it used test subjects with low vision, so they were basically thrust onto the roadway at these roundabouts, and they had to determine from themselves when it was, you know, their turn to cross. Of course, they had people with them to pull them back onto the side of the road if it wasn't the right time to cross. Basically, the outcome of the study was single-lane roundabouts seem to be accessible to the same extent as similar signalized intersections. But multi-lane roundabouts, in this case, 2-lane roundabouts, were considered inaccessible without additional crossing treatment. So that was a pretty significant finding. And the reason for this was that the multi-lane roundabouts, of course, had higher speeds, higher volumes, and also the potential for a multiple threat crossing. And a multiple threat crossing is, you know, a visually impaired person can detect or hear that someone in the near traffic lane has stopped or yielded to them. They step out on the road, and of course, someone in the next lane goes whizzing by, doesn't yield. And there's no way for the visually impaired person to detect this. So that's called a multiple threat crossing. The willingness of drivers to yield pedestrians seemed to be increased by installing a raised crosswalk or using pedestrian beacons or signals. So the conclusion of this study is multi-lane roundabouts are inaccessible unless you install a raised crosswalk or pedestrian beacons or signals. And that's basically the position of the blind community. So here's the tool that we have now in Ontario at our PXOs, the rapid flashing beacon, which is a high intensity LED with a stutter flash that is pedestrian actuated. And has been shown to increase driver yield heights to pedestrians by more than a standard non-LED beacon and by almost as much as a red display, right like at a signal. But it is very important to note that it is not the regulatory device. The regulatory RA5 sign is the regulatory device, and that is the means by which priority is conveyed to pedestrians. So it's not the beacon, it's the sign. There's other treatments out there that can help increase accessibility, raise crosswalks, as we mentioned. And I think that's just by, that just helps motorists slow down. As motorists slow down, they're more likely to yield to pedestrians. On the top right, crosswalks farther from the roundabout, and that will help separate the sound of circulating traffic from the sound of entering and exiting traffic. So that helps pedestrians detect or able to hear and differentiate, when motorists have yielded. So I think it just helps them, separate all these different sounds. At the bottom, low height landscaping, that really does nothing to help low vision pedestrians decide when to cross, but it helps them find where the crosswalk is. And of course, tactile walking surface indicators, which are helpful everywhere. And it just, denotes the edge of the roadway. Just PXOs, of course, these are in OTM book 15. And these are signs only. So this is the PXO type D, the PXO type C, which supplements the signs with the beacons over top of the signs. This is an example for a 2-lane roundabout. And the PXO type B, which supplements the signs with the beacons and the overhead component. There's a selection matrix, of course, in OTM book 15, which helps you decide, which of these PXO types do I use, particularly at a roundabout. It's an interesting table. I like to kind of blank out some of the, do we use the 4-hour volumes, the 8-hour volumes? The idea of the table is that it suggests that the type of PXO be determined by vehicle volumes. So in the case of a roundabout, we would use a 1 or 2-lane column and go from there. However, municipalities are struggling about particularly the when to implement the type B and C PXOs, which supplement the regulatory sign with the beacons. If you use that selection matrix in book 15, you can end up with a mix of PXO types for different legs of a roundabout, and even differences between entries and exits of the same leg. So that's if you strictly apply that selection matrix. RFBs add a security and accessibility component at roundabouts, but they do not necessarily increase pedestrian safety, especially since, drivers think that, maybe it's the beacon that provides the right-of-way device and not the sign. Right, so overuse of the RFBs may condition drivers into thinking they're the regulatory device and not the sign, especially since the sign is new in Ontario. So far in Ontario, we've had a consistent application of RFBs at roundabouts so far. Just a couple more things. It's interesting to note the crosswalk setback change between the January 2015 draft and June 2016 final versions of Book 15. In the January 2015 draft, this is what it looked like. We had a 6-meter dimension between the crosswalk and the yield to pedestrian line, and then a 6-meter desirable dimension between the line and the roundabout. And that's what it looks like here. And then in the final version, that 6-meter desirable was changed to 6-meter minimum. And a 12-meter minimum setback is problematic at constrained locations as it can block nearby driveways. But it's important to note that the forward of every OTM does say that that basically the OTMs are guidelines, right? And they should not be used as a substitute for judgment. And finally, what about convenience? Well, A roundabout takes pedestrians more out of their path of travel for a crossing movement through the intersection, more so for a 12-meter setback than a 6-meter crosswalk setback. So the crossing distance or walking distance is longer with the roundabout. However, waiting times for pedestrians are usually much shorter than at signalized intersections. So in terms of convenience, roundabouts and signalized intersections are probably, they could probably be considered a wash. So, conditions for cyclists at roundabouts. Recent research from Northern Europe suggests that roundabouts may actively increase the frequency of cyclist crashes. This is a bit of a departure from earlier research, which suggests that roundabouts may actually be helpful for cyclists. So this is some interesting new findings. The research has always been a little bit inconclusive in this ground. Some research said that roundabouts decrease cyclist crashes. Some research said they increase. So it's always been inconclusive. But some of the more recent research is saying that roundabouts are not as favorable to cyclists. But the research has always said, or the experience has always said, that carrying bike lanes through a roundabout is bad. It is the least safe design for cyclists, and that's because it keeps them to the outside of the circulating road, where they are not visible to exiting drivers. And it's always been consistent that single-lane roundabouts are considerably safer and feel safer for cyclists than multi-lane roundabouts. So that part has not changed. Approaching a roundabout. If a roundabout is on a road with bike lanes, then the bike lanes terminate before the roundabout and resume after. So again, we don't carry them through the roundabout. Here's an example on the bottom right of that. So the bike lane terminates before the roundabout, and there's that ramp to the sidewalk. A roundabout can also be on a road with one-way cycle tracks or a two-way multi-use path. And here's the multi-use path example. In Ontario, cyclists are considered vehicles. So when bike lanes terminate before the roundabout, cyclists can take the lane and ride through as a vehicle. That is the one option. Motor vehicle speeds are similar to cyclist speeds at single-lane roundabouts, although they can be higher at multi-lane roundabouts, especially if drivers ignore lane markings. The OTM Book 18 update is likely to show more cycle tracks and fewer bike lanes at roundabouts. Cyclists are expected to dismount and walk their bike when using a pedestrian crosswalk or PXO. This means we will have no cross rides at a roundabout. And here's just an example of a roundabout with cycle tracks. So we are going to start to see more of these. This is an example from Ottawa. So I showed an example earlier of a two-way multi-use path. These are one-way cycle tracks. Some more safety findings. Observations and crash data suggests that when cyclists take the lane, this can lead to conflicts and crashes between circulating cyclists and entering drivers who may have looked but failed to see, and thus failed to yield to the cyclist. Providing separated cycle tracks around the roundabout seems to be a lower risk and more comfortable design treatment. So this seems to be the way to go if you're able to do it. However, this does relocate the conflict point between drivers and cyclists to crossings upstream of the entries and downstream of the exits. Requiring cyclists to always be the one to yield to drivers, although safer for cyclists, is not all that convenient. And just to take a little side trip for a second, radial versus offset left design, which you're saying, yes, what is that exactly? So we'll talk about that for a bit, and then we'll go and see what they do in the Netherlands. So low speeds and safety. So controlling speeds through a roundabout is essential for safety. Key to this is controlling entry speeds. If entry speeds are too high, there will be a high probability of drivers not yielding to circulating traffic. So the most common crash type at a roundabout is what we call the entry circulating crash. Low speeds also give pedestrians, cyclists, and drivers more time to judge gaps and react to each other, and making any crashes that do happen less severe. So low speeds are the key, and low entry speeds are the most important of all. Well, there's two types of entry alignment we can have at a roundabout. One is called the radial design, and one is called the offset left design. So radial design or radial entry alignment basically maintains the approaches on alignment and controls vehicle speeds by deflecting them around the central island. And a typical ICD, and I'm using a 2-lane roundabout as an example, although this could be single lane as well. A typical ICD, or inscribed circle diameter, for a 2-lane roundabout with a radial entry alignment is about 60 meters. Offset left entry alignment takes the approaches off alignment so that the center line passes to the left of the roundabout center. We can use a smaller diameter to create the same amount of speed control on the entry and accommodate the same design vehicle. But we will have greater impact on the left side of the roadway, and we will have less exit curvature. So you see we can use an ICD of 50 meters instead of 60 meters. And as we say, same amount of speed control on the entry, accommodate the same design vehicle. So with the radial design, we can estimate the fastest path speed from the methodology used to measure entry path deflection. Now, I haven't showed you all that, but suffice to say, this is how we measure entry path or fastest path speeds, right? So the fastest path speed on the entry, right? The entry path radius is 60 meters. The fastest path speed is about 42 kilometers an hour. All right. The fastest path exit speed, all right, if we measure the arc on the entry and physically measure, is about 48 kilometers an hour. All right, so the fastest path entry speed, the fastest someone can go through the entry if they're driving as fast as they possibly can, is 42 kilometers an hour. And the fastest they can possibly go through the exit is about 48 kilometers an hour with this design. So there you go. Things are actually a bit different with an offset left design. So if we've applied the same philosophy, we have exactly the same entry speed, 42 kilometers an hour. But if we measure the radius of the path on the exit, we actually get 72 kilometers an hour. Now, if you're looking at it, you say, is it actually physically possible for someone to be going 72 kilometers an hour on the exit of this roundabout? That seems awfully fast, doesn't it? So there's actually two ways we can measure the fastest path exit speed. One is to measure the vehicle path. The other is to measure acceleration from the circulating speed. So the entry speed is 42 kilometers an hour. They actually have to slow to 34 kilometers an hour as they circulate. And then what we do is we measure acceleration from that point to the exit. And when we do that, we find that the exit speed is 53 kilometers an hour. So the governing fastest path speed on the exit is not 72 kilometers an hour. It's in reality 53 kilometers an hour. However, that's still faster than 48 kilometers an hour. So you can see the difference between these two designs, right? With the radial design, we have a larger footprint, but we have a slower exit speed by 5 kilometers an hour, which is significant. That's a trade-off with these designs. So for the same entry speeds, radial designs result in lower exit speeds, which is good for pedestrians and cyclists walking their bikes. However, again, for the same entry speeds, radial designs take more space. And radial designs have a higher probability of something we call vehicle path overlap on multi-lane roundabouts as drivers transition from entering to circulating and for circulating to exiting while trying to stay in their lane. So the more appropriate type, radial or offset left, should be a case-by-case decision. Question choice of design vehicle, right? If we don't need to design for a big truck or whatever, then that can change the choice that we make, right? Because maybe we've decided on an offset left design because, well, we don't have the space for radial design. But if we can use a different design vehicle and reduce the footprint, well, maybe we now do have space for radial design with the advantages that it provides in terms of lower exit speeds. So these are all things that we should be questioning as we go through the roundabout design process. Roundabout design in the Netherlands. They have two types, again, two types. One is called the cyclist priority design, and one is called the vehicle priority design, or the non-cyclist priority design. And they both have some differences. Here's the cyclist priority design of the cyclist priority roundabout. You may have seen pictures like this before when you look at roundabouts in the Netherlands. It's a radial design. Cyclists and pedestrians have priority over motor vehicles. And the cycle track, red pavement in this case, is one circle and continuous so that cyclists can maintain their speed through the crossings. Signs and markings instruct motorists to yield to cyclists and pedestrians. Here's the vehicle priority roundabout. Again, it's a radial design, so both roundabouts are radial designs. In this case, though, motorists have priority over cyclists and pedestrians. The cycle track, or red pavement, is discontinuous, and cyclists must slow and make a perpendicular turn at the crossings. Signs and markings instruct cyclists and pedestrians to give way to motorists. So you can see there's a couple major differences here, right? In the cyclist priority roundabout, the cycle track, or the red pavement, is continuous through the crossing. And here it's discontinuous. In the cyclist priority design, the cyclist can cross at speed because the design basically instructs them to do that. Here, the cycle track makes an abrupt turn, so the cyclist must physically slow down to cross. So two very different messages that's being given by the geometry and by the signs and markings. Here's what it looks like at street level. So here's the cyclist priority crossing, and you can see the very smooth track for the cyclist, right? And the continuous red pavement through the crossing. And here's the vehicle priority crossing. So the red pavement's discontinuous. You can actually see the yield markings, the triangular markings for the cyclists in this case. And you can see that at either end, there's this discontinuity where the cyclist has to slow and turn to make the crossing. So the messages are very clear about who has priority. The signage is also clear as well. So you can bet that on the top one, the yield sign is facing the motorists. On the bottom one, the yield sign is facing the cyclist. One-way versus two-way cycle paths. So the perimeter cycle tracks are intended for one-way circulation, and that's counterclockwise to the cyclist, the same direction as for the motorists. So if you're a motorist approaching the roundabout, you're looking for cyclists in the same direction as you're looking for circulating traffic. So it'll be counterclockwise. So if you're approaching the roundabout, the cyclists will be coming from the left, the same direction as the circulating traffic. However, if enough cyclists are riding clockwise because of high left turn demand, for example, then the cycle path will be formally designated as two-way, like a multi-use trail. So they won't ignore that. They will formally designate it as two-way. However, to counter the extra workload for approaching drivers that now have to look for cyclists in both directions, the crosswalks and cycle tracks will usually be raised like a speed table. Right, so there'll be an extra treatment that will accompany this, because drivers won't normally be expecting it. However, at multi-lane roundabouts, most cycle tracks are grade separated in two-way. So they usually grade separate cycle tracks at multi-lane roundabouts. Must be nice, right? Have that kind of money. But that's what they do in the Netherlands. And typically they don't have bike lanes in the Netherlands. If there's on-street parking, 2 or more lanes per direction, or motor vehicle speeds of 50 kilometers an hour or more, no bike lanes. And here's this one of their lovely grade separated cycle tracks at a multi-lane roundabout in the Netherlands. Looks lovely. Also note in the Netherlands, almost nobody wears bike helmets. It's very interesting. Just some statistics which are also quite interesting. Vehicle priority roundabouts are about 70% safer for cyclists in signalized intersections, while cyclist priority roundabouts are about 45% safer for cyclists. So actually the vehicle priority roundabouts are safer for cyclists than the cyclist priority roundabouts. Nevertheless, virtually all roundabouts in urban areas are cyclist priority roundabouts. And the reason for that is a concerted effort to make cycling convenient for people. So despite the safety statistics, in urban areas, virtually all roundabouts are cycling priority roundabouts. Now, the difference in actual cyclist crashes between vehicle and cyclist priority roundabouts are really not all that great. And both designs are still much safer for cyclists than signalized intersections. So despite some of the numbers I gave earlier about cycling or about roundabouts not being safe for cyclists, in the Netherlands they are, at least when all these features are applied. And of course, they're grade separating cycle tracks at multi-lane roundabouts, so that's certainly going to be safe. So with that kind of data, that's what they're doing. So again, vehicle priority roundabouts may be slightly safer for cyclists because this isn't actually a huge number. Although vehicle priority roundabouts are safe for cyclists, cyclist priority roundabouts are the norm in urban areas. And the reason for that is convenience and promotion of cycling as a mode of travel. Pedestrians are also mostly consistent in that zebra crossings are used where they have priority and parallel lines are used where they do not have priority. And consistency for all modes is seen to be a benefit to overall network safety. And just to wrap up with some concluding thoughts. Actually, I'm ahead of schedule. All right. Studies are limited, but they show that single lane and multi-lane roundabouts are generally safer for pedestrians than signalized intersection. Multi-lane roundabouts don't always feel as safe, and they are not as accessible. That is kind of a given. So that's one of those things that must be weighed against the other benefits a roundabout will provide. RFBs can add a security and accessibility component at roundabouts, but they do not necessarily increase pedestrian safety. Roundabouts are not always safer for cyclists, especially multi-lane roundabouts, but good design can help maximize safety for all users. So what do we do about that? So maximizing pedestrian safety, low vehicle speeds, entry and exit, short crossing distances, and we can do that by fewer lanes, especially at the exits. The most appropriate crosswalk setback, that's 6 or 12 meters. Splitter islands wide enough for a refuge area, so pedestrians only have to watch for traffic in one direction at a time. And that's a minimum of 2 meters to accommodate strollers, wheelchairs, and cyclists walking their bikes. Good sight lines between pedestrians and approaching drivers, so that means no parking on the approaches, signs that don't block waiting pedestrians, and street lighting that illuminates crosswalks from the front. And finally, appropriate use of RFBs and pedestrian signals. So it doesn't necessarily mean everywhere, but it means at appropriate locations. And how do we maximize cyclist safety? Low vehicle speeds, entry and exit, fewer lanes in the roundabout, ideally a single lane roundabout, but of course we can't do that everywhere. If possible, one-way cycle tracks around the outside of roundabouts so that cyclists circulate counterclockwise, but again, we can't necessarily do that everywhere either. But that is preferred to a two-way multi-use path where approaching drivers must look for fast-moving cyclists in two directions or bike lanes that terminate before and resume after the roundabout. Most appropriate crosswalk setback, 6 to 12 meters. Splitter islands wide enough for a refuge area so cyclists can complete the crossing in 2 stages. And consistent messaging about who has priority at crossings. Finally, just a word about signage. Again, this is a work in progress, but I just really feel we have too many signs that are roundabouts. Here's a roundabout. This is the pedestrian signage that we have at our roundabouts, right? This is out of book 15. Here's some signage that we have for our bike lane terminations and reentries, right? And they look, you know, in isolation, you go, okay, well, I've got a few signs for this. We've got a few signs from that. But when you combine them with all the other signs we have for our roundabouts, it's a lot of signs. So I really hope in the future we can start doing away with a few of the signs that are roundabouts. That's it. That's all I have. Are there any questions?
Thank you, Phil. That was a wonderful presentation and was very informative. With that, I'll open the floor to questions. We have one question from Rahman Mustafa. Please go ahead with your question.
Yeah, thank you, Weber, for a nice presentation. It was really very informative. So I have a few questions.
Mm-hmm.
Number one is that, as you mentioned, at Roundabout, if we install PXO, cross right is not allowed or prohibited. But from our practices, we have seen a couple of municipality has introduced combined cross ride at Roundabout. Why cross ride is problematic at Roundabout? I know HTA, it dictates that it will create contradictory right of way. That's the number one question. Number one question, you mentioned that crosswalk further from the roundabout could be an option. Why it would be better than just 6 meter offset from roundabout? And number three is you mentioned about vehicle priority roundabout. Collision at vehicle priority roundabout is less than the cyclist priority from the statistics. So I don't understand why, because we are providing a lot of priority for the cyclist priority design, but whereas vehicle priority roundabout has less number of collision. Thank you.
Thank you. I'll try to remember those questions in order. So the first question had to do with PXOs and cross rides. I mean, the decision's been made not to provide cross rides at a roundabout because it's not controlled by a stop sign or a traffic signal. So to provide a PXO under those conditions, or sorry, a cross ride under those conditions is not, I mean, right now, those are the only locations where cross rides are being provided, right? So a roundabout doesn't have those types of control. So that's something that one of the problems is when you have a cross ride, you're having, unlike a crosswalk where pedestrians are moving at relatively low speed, when you have a cross ride, you have the potential for fast moving cyclists, right? So you have no mechanism by which you can stop approaching traffic, right? In advance of the cyclist crossing. So that's the problem. Like when you have a signal, right? You have the approaching drivers governed by the red signal. With the roundabout, you don't have that. So there's the reluctance on the part of the powers that be to provide a cross ride, is that you don't have that, or the stop sign, right? Similar thing. You don't have that type of control at a roundabout. So that's the problem with providing a cross ride, is that lack of control. Does that answer your question for question number one?
Yeah, for sure. Yes. But at PXO, pedestrian is getting some sort of priority.
Yeah.
Through because we are installing PXO. So
yeah.
And
but there's that
cyclist is supposed to dismount.
Yielding, right?
Yeah, cyclist is
but
supposed
you don't
to.
have that with the. Yeah, you don't have that opportunity if if you have a pedestrian, they step up to the side of the road, there's an opportunity for eye contact and making sure that the driver is yielding. And when you have a cyclist, potentially they could be whizzing across the road without checking that the driver has done any of that, right? So it isn't the same mechanism or opportunity.
Exactly. Sometimes they misjudge the gap and they just try to cross the.
They just blow across.
Yeah.
So it's a different dynamic.
But I heard that there is something on the way regarding accommodating cross ride at roundabout. Do you know anything about that?
No.
Okay.
My understanding is that that's not happening.
Okay.
Yeah, I could be wrong, but that's my understanding.
No, thank you very much.
Yeah.
Yeah.
Well, so you had two more questions though. There's question two was, no, I can't remember. I know
Okay.
one was Dutch design vehicle versus cycling priority designs.
Yeah.
And yeah, the vehicle priority designs are technically safer for the cyclist because the cyclist is now responsible for their own crossing, right? So they're making sure that the motorist has stopped before they
Exactly.
cross.
They are not getting false sense of security that it's our priority. So I understand. Yeah.
Right.
So if you are, maybe we are on the same page. Like.
Yeah.
Okay.
But again, it's not as convenient for the cyclist. Especially in urban areas, you can imagine you have successive intersections that are roundabouts. If they have to stop at each one, it's certainly not convenient for them, right? And that's the reason that the Dutch government has decided to make it cyclist priority at all these locations, even though they might take a hit in terms of safety. It's the numbers have shown it's actually not a big hit, but the safety the convenience benefit is huge. And when you're talking, huge numbers of cyclists, it's a big deal. So they've decided in favor of convenience. So, safety is one thing, but it isn't always everything. So they've decided in favor of promotion of the mode. So, so that's their decision. So, and I get it as a cyclist. Like if you're traveling along a road and you have crossing after crossing after crossing, if you have to stop at every one for the driver, you may decide, I'm not going to cycle to work anymore. I'm going to take another path. I'm going to do something else, right?
Or they can.
There's long-term, societal disbenefits to something like that, right?
Yeah. Yeah.
So that's the decision they made is an overall societal gain to be made by promoting that mode by giving them priority.
That's wonderful. Thank you. And the third question was a crosswalk further from the roundabout. I have seen one design you have shown. So what are the real benefit of having this kind of crosswalk?
Yeah, it's, it should be a case by case. Sometimes closer is better. Sometimes farther is better. It depends on, it depends on how far, but it depends on local conditions and the design of the roundabout itself and things like that.
My understanding is that once a vehicle entered to the exit from the roundabout, they try to speed up. And if they have to stop again for crosswalk further down the roundabout, it will be more dangerous than bringing it closer to the roundabout.
Yeah, if it's 6 to 12 meters, that's still relatively close. If we're talking much further away, like that one example I gave, then that becomes a mid-walk crossing, basically.
Yes, mid-walk crossing. Yes, exactly.
Yeah. Yeah.
Okay, thank you very much for your excellent presentation.
You're welcome. Thank you.
We have another question from Sean. Sean next. Sean, please go ahead with the question.
Phil, thanks for the presentation. I want to pick on the very last slide that you put up because it's very telling. I'm very curious. It's a three-part question. One, is this actually an excerpt from a typical layout that's found in one of our illustrious guidelines? Part two, if it's not, can you actually post this in a social media campaign to encourage people not to do this? And three, if it is, can you please post this in a social media campaign to prevent us from doing this? Because I'm seeing this more and more. I'm even recalling a couple of safety reviews that I've been involved with, not necessarily with roundabouts, but with a number of other corridors where the signs start to creep back in. And it's really going against what we're trying to promote, which is anti-information overload in a very complex environment where timely reaction is everything. So very curious on your comments here.
That graphic does go back a number of years. That's why it probably looked a little fuzzy and dated, but the information that's contained in it is current enough. I'd be happy to share something like that with you. I'd probably make it a little bit more current before I do, but like I said, it's current enough in that it does reflect relatively recent practice. So yes, I've always been kind of beating the drum about we don't need all these signs. It's one of those things where a lot of a lot of countries have kind of done this through the roundabout evolution, where when you first start out with something, you compensate for the lack of education by adding signs, right? And then as drivers get used to things, you can start gradually removing signs. And I'm hopeful we can do that as we progress in our, in our journey with roundabouts. But there's always that, tendency to err towards caution and, well, maybe we need the sign, maybe we don't, well, we better put it in anyway type of thing. And it's very common, everybody does it. But a colleague once told me years ago that, in France, there's 10 pages on how to drive a roundabout, and they have 20,000 roundabouts in France, right? So here we have a fraction of that number of roundabouts, and we have 2 pages in our driver manual, right? So how do we make up the difference? We add more signs, right? So once we get more roundabouts and more pages in our driver manual, we can remove signs, because when you drive a roundabout in France, you'll probably notice a quarter the number of signs at their roundabouts. So it's just the natural progression of things, right? As people get more familiar, as people are brought up driving roundabouts, as they learn about them in the driver manual and on driver courses, well, you don't need all these signs anymore, So it'll happen gradually, eventually anyway, but yeah, I'm certainly hopeful that people like you and I can push the process along as best we can.
Thank you.
Yeah, but I'll contact you offline, and maybe we can share some information and try to push it.
Sure, thank you.
Yep.
We have another question from Omar Shams. Omar, please go ahead with your question.
Thank you, Shiva, and thank you, Phil. So my question would be a combination of the 3 presentations plus follow up with Sean's question. With the whole advancement of technologies in the autonomous vehicles and the automation in general, how challenging would that be to navigate and go through 20 different signs approaching to the roundabout, and then navigate through the roundabout, and then identify and all the objects, the moving objects, pedestrian and cyclist within the roundabout, and safely cross this? Where do you see this whole realm of introducing and the roundabout being more ubiquitous into our systems, but also ensuring that the safety of cyclists and pedestrians are maintained within this environment, given that we're also expecting more so proliferation of all these automated vehicles in our system? So just a high-level thought would be great.
Mo, Anastasia, either you want to field that?
I have nothing to add to that. But great presentation, great question as well from Omar.
Yeah, it's a great question. I guess one thing I find a little disconcerting is that I'm part of a roundabout community. We chat on a listserv, and it's a relatively small profession in the grand scheme of things. I find a little disconcerting that not one of these big companies has reached out to any of us to ask us any questions about roundabouts, or are we programming these things into our GPS systems correctly or anything like that? It's like nothing. It's like, yeah, it'd be kind of nice for us to reach out, or for one of them to reach out and say, are we getting any of this stuff right? They just assume that they have, I guess, right? But are they?
That would be an assumption, right? But it's I think it's more upon us as the working professionals within the industry to ensure that these communications are taking place in the future of our infrastructure investments, but also investment in the new technologies, are more so moving in a direction that's more sustainable and done correctly in the long term. But definitely, I see that there is probably a communication gap, as you're stating, that no one has reached out to this committee, and that's a big surprise to me. But certainly, I think there's more work to be done, specifically on ensuring safety of pedestrians and cyclists within a roundabout environment. And we're even concerned on just on how these future technologies are reacting into and incorporating cyclists and pedestrian safety in the system. So that's a very good response, and I'll see if there's any opportunity for maybe connecting some people with the committee, especially from the AVEN Society, which is Autonomous and Automated Vehicle Innovation Network with the province of Ontario, with yourself and the committee, and especially with the TAC to ensure that they're getting things right.
Yeah, some of us have tried to reach out to Google, for instance, to make sure that their instructions for navigating a roundabout are correct, but they never get back to us. So
yeah. Thank you for the presentation and for the response.
I will give it a minute for any more questions. I don't see any more questions. So thank you, Phil, for answering those questions. Before we close, I would like to let everyone know that the CITE 2021 virtual annual conference will be held next week from June 8 to June 10. The registrations are still open and the sponsorship opportunities are also available. Information about the conference is available on the CITE website. This is the CITE website. From the Events and Training tab, click on the drop-down link for the 2021 CITE virtual, which will bring us to this page, and this page then provides the link to the annual conference website. And this is the CITE virtual conference website that has the links for registration and for the sponsorship information. With that, I will once again thank the speakers and the attendees of this event. I would also thank the Hamilton Section's Executive Committee members for their cooperation in bringing this virtual event together. We are planning to organize our next virtual event tentatively in August 2021. Until then, stay safe and healthy. Thank you and have a wonderful day. Bye for now.
Thank you.
Thank you, everybody.